Hey guys, good morning and welcome back. So exciting, fun times. We're in the Kermit room here, we're calling it. We're getting ready to get our Rosie and our Hawke's Bay going so we can continue testing here in Florida. We've got the Rosie E-panel pretty much all wired up. This is a prototype, so it's a little, ugly inside. My wiring makes it even more ugly. I brought all the AC and DC wiring through the back. The only thing you're going to see when this is all done is the battery cables going to the server rack batteries that aren't here yet. So we're going to go ahead and put the covers on this, and we're going to talk a little bit about SPDs today. In this this breaker panel has a bunch of extra breakers in it that we're not using. Those are there because we don't have our filler plates yet. So this E-panel is all cast aluminum, kind of real elegant, nice. It's got the bypass, the battery breaker, of course, as a normal E-panel would. And you may be asking why I wedged these in the corner so tight against each other. I have this room is our laundry room, plus it has a freezer and everything else in it. You'll probably see us doing a lot of videos using the freezer as kind of our, our bench, if you will. We've got a lot of exciting videos coming up that we want to do, like comparing some surge arresters, which I'll show you here in just a second. Let's go ahead and get this cover on the Rosie. Rosie likes to be dressed up. And Midnite hollered at me because I always use the power drill to put these screws in and out. They tell me I was stripping the instead of screws out. So that's what everybody else is going to do. So what I wanted to do today was talk a little bit about surge arresters, how you wire them, what they do, why you want them, etc., etc. You can notice that we've got 4 already on here. These 2 are AC. This is AC in and this is AC out. So these are protecting both sides of the Rosie. So if we get a lightning strike here in Florida, in theory the Rosie should be safe. You'll notice they've got 2 blue lights on. That's L1 and L2. L1 and L2. You'll notice these are both blue, and this one's red. It's October, end of October. So usually in October, Midnite switches to red. November, they switch to green, and that's kind of to celebrate Christmas. They ship some red and green SPDs around Christmas. Everybody gets a... No, I'm just kidding. There's really no difference. The difference is the manufacturer of the MOV. So the standard MOV Midnite uses is the blue one. I don't know the manufacturer, it doesn't matter. But they also have another distributor that makes the red ones. And they just use, if they have a shortage of these, they use the red ones. So you might see different color. You might see green, you might see red, you might see blue. The common one being blue. So where do you use SPDs? And what is an SPD? Let's start there. So an SPD basically is a surge arrestor, and its job is to try to keep all 3 wires or 4 wires, depending on which SPD you have, at the same potential. So let's say you take a lightning strike out here in the yard, and there's an induced voltage, probably not a direct strike. We'll talk more about nearby strikes. Your neighbor's house gets hit by lightning. There's induced voltage everywhere. This piece of wire will gain voltage. It's an antenna. So when you've got a wire in the ground, a wire in your house, it senses that voltage and it rises up. What happens is when this red wire tries to go to a high voltage, it shunts it to the green one and keeps everything at the same potential. So the Rosie, for example, as long as every terminal in the Rosie comes up together, the Rosie can take like 3,000 volts, whatever. It's not going to matter as long as everything comes together. If you put 3,000 volts on DC plus and 0 on DC negative, Rosie's going to complain and break. But if you put 3,000 volts on everything, Rosie's okay. So when they go through UL listings, whichever NRTL, National Recognized Testing Laboratory they use, they do these things called high pot testing, where they apply I think it's around 3,500 volts to these and make sure it doesn't leak to the case anywhere. And these devices can all do that. So that's your goal, is to put an SPD wherever you think you've got something valuable. And my general rule of thumb I use, and everybody has a different theory, and if you live in Florida, lightning, everywhere, you may want to err a little bit more on the let's do more than less. you live somewhere where there's never been a lightning storm in your life, then maybe it's not quite as necessary. But my general rule of thumb is to put one at every end of every wire that's longer than 50 feet and has anything worth protecting. So what I mean by that is if you've got a building that's 100 feet away from your house and you've got to feed a wire that goes out there to a breaker panel and you have something in that building that's valuable, then you probably want a surge arrestor on that breaker panel because that 100 feet of wire is an antenna and will pick up that voltage. If the only thing in that building is maybe a $20 fan or a $100 air conditioner and nothing else, then you may decide it's not worth the extra cost. So that's kind of my rule of thumb, is I put them anywhere where it makes sense. Every breaker panel, every input and output of an expensive inverter, every charge controller. This one has a 115, Midnite SPD 115 on it for the DC side because we're using lithium batteries. And I used to say don't use them on the DC side because it's a waste of money, because a lead acid battery is a great surge arrestor. It's a huge capacitor. But now we're all going to these lithium batteries. They all have these computers in them called BMS, Battery Management System. And if you get a bad surge induced into this whole system, that BMS can be damaged just like any other computer. So now we're using the 115 on the DC side to protect that. And then this is an SPD 600 to protect the Hawke's Bay input. We'll show you a little bit more about where to wire them up in a second. But yeah, that's kind of the thing, and what you use for an SPD is entirely up to you. We're going to do a really fun video. You'll notice I've been picking on the poor Delta here. We're going to do a really fun video where we show you what these actually do, what's inside them, and what you're getting for your money. I'm going to give you a clue. If you're buying one of these and your distributor told you this is a surge arrestor, they flat lied to you. Everybody that sells these knows that these do absolutely nothing. Well, I shouldn't say they do absolutely nothing. We'll save that for the video. But they don't do hardly anything. They are an air gap instead of a surge arrestor. So they take tons of voltage to arc over, and by that time everything is blown up. So if you're getting sold one of these by your distributor, you're getting the short end of the deal. You want to be looking for something by Midnite, Cytel, something like that. You want to look for something that's actually got like MOVs in it, that's actually got some surge arresters. So this is a Midnite SPD 300 AC, and you'll notice, it's got 3 wires, red, black, and a green. It comes in a box. Inside the box you get your instructions. And we'll save those because we're going to use it for a future video. You get a lock nut, silicone ring, and a piece of white heat shrink, and I'll explain the white heat shrink. These are 4X rated. They're meant to go right outside on a combiner box so you can see the blue lights if they're working. And the silicone washer goes in here to seal against the box once you put it in outside. If you're using it inside, you don't need that. And the white heat shrink is if you're using it on, say, a DC system where the negative is, let me get this right, solidly bonded, which is a fun topic we can talk about all day long. If the negative is solidly bonded, it's supposed to be white. If it's reference grounded, then it's supposed to be black. So like this black wire over here that I put in on this SPD right here, this needs the white heat shrink put on it. This system will be solidly bonded because we're using the new ground fault in the charge controller, allowing us to bond the negative. But that's what you're looking for an SPD. We have this one. I think street price on these is around $90 to $100. We do have this guy here that we bought to do an upcoming video. We keep seeing these, hearing about these. They're going to protect you from an EMP, a nuclear blast, everything. They're going to save your lawnmower. They're going to save your house. They're going to save anything you put one on, your dog, anything. They're quite pricey. I think we bought this, all open fairness. We've purchased everything you see here to do this test. We did not ask anybody for anything. And we're going to crack this open. We're going to dig the potting out of it. But before we do that, we're going to show you in the video that we're going to do what it does, how they conduct. We're going to hook everyone up to high voltage. We're going to show you the voltage at what they start to conduct over at to protect your devices. But we're really excited to tear this one apart because we're really curious what's actually inside it. This is an AC one, and kudos to EMP Shield. They actually give you a white wire. I don't know if it does anything internally, but they give you a white wire. The Midnite one you'll see has got a red and a black wire. So this example we're using out here, we're about 40 feet from our main panel. And you may say, why do you want a white wire? your white wire and your green wire in the US and Canada are bonded together with a hard bond in your main electrical panel somewhere, in your main electrical service, your system, if you will. Typically it's done in the meter socket or the main disconnect of the building. Like if your main disconnect is in your basement and breaker panel, the meter socket's outside, the bond will be in that main disconnect. So at that disconnect, these are exactly at the same potential. But now out here, 50 feet away, if lightning strikes right out back here, this neutral could actually come hot because that 50 feet of wire has quite a bit of resistance where you're talking thousands of volts in a lightning strike. So in a sub panel, you really do want to protect that neutral. So what I do is I actually use a second SPD and I put my black wire on the neutral and sometimes even my red wire. But I'll use an extra one of these. And remember, I said I think we paid about $400 for this. We paid about $90 for this. So for $180, I can get 2 of these, and I still have, you know, $220 left in my pocket. This will be interesting to see what's inside it. We're just going to leave that there for now. That's a whole other video. We really may even be a series. We really want to take some time. We want to show you guys what's inside these. We want to show you the voltage, but we're trying to focus mostly on the SPDs, where you install them, how you install them. So I'm going to kind of move around a little bit on you here so I can do some pointing. And you'll notice in the Hawke's Bay breaker box, so this is a 600 volt charge controller. Midnite is giving you a lug here for your negative SPD. They've given you a lug here for your positive to your battery on your SPD. And then they've given you this little jumper block right here for your 600 volt on your SPD. Now you'll notice I've already hooked this up because it's really hard to see, especially on camera. But way in the back there's a ground bus bar. And we've run the ground wires to that bus bar. The one thing you want to do is you don't want to make a sharp bend in the wire like that and go into something, because lightning will come out of a sharp bend. It doesn't like to turn corners. So you want to keep these wires as short as possible. So like in our case, we're probably going to keep them about like that. So I'm going to go ahead and hook these up. I think I can duck down. You guys can watch over me, and I'll go ahead and hook these up. I've got my tools right here. And you always want to make sure the power is off when you're doing this. You don't want to be doing this live, for sure, especially at 600 volts DC. So we're going to cut that right about there. Strip back the appropriate amount. Make sure our screw is loose. Tighten it down in there. Put that anywhere. There's gravity, right? And that's really pretty much it. You see that just kind of sets in there. Those are nice. They don't have any sharp ends in them. Same I did with the negative. Like I said, I do have to put the heat shrink on here, but I don't have my heat gun out here with me today. What I'll probably end up doing is putting some white phase tape on it instead, because that's easier than going and finding a heat gun. But that's kind of it on the SPDs. Like I said, just kind of a recap. Everywhere you can basically put one that will protect something you want to protect. Your first line of defense is if you're utility connected, right in that main panel. Like if you were to look at our main panel here in Florida, there's one actually on the weatherhead, and you just split bolted right into the service head, so the utility just hangs right from the weatherhead. Utility does that one. And then there's one in the main breaker panel, which the electrician puts in when he installs the breaker panel. And then like I said, this here we're putting them on the Rosie because we want to protect the Rosie. But like say we had a garage 100 feet away, we definitely put them in the garage as well. And we're probably even going to put one in our camper. We have the Victron system in the camper, as you know. And if not, we have a playlist in our somewhere. Sue will explain to you how to get there. But it's like if you click on our channel, there's like playlists, and you can probably find something about our solar, and you'll see the camper. We've had a friend that had his camper not hit by lightning, but the lightning hit across the road. that came in his camper, it fried a bunch of stuff. You can buy the really expensive, you know, surge arrestor thingies that plug into the power pole at the campground and you plug your camper into it. They basically do the same thing. Some of the better ones actually have contactors and won't connect the camper until it's approved everything. In our case, we have a Victron inverter. It does the same thing. Victron looks at that campground power, and if it's way out of spec or the neutral's gone or something like that, it's not going to connect. It's just going to say, no, something wrong. So in our case, we can put something like this right in the camper and protect everything in the camper with one of these. So that's, you know, a good idea too if you've got a solar system in your camper. If you don't have a solar system, you're probably better off to get one of those that qualifies. You can plug it in. I'm not sure. I'm not completely sold that campgrounds are that bad, but all the big channels you watch on YouTube of all the campers, full-time campers, they all swear by them. But I also don't see a lot of videos about everybody losing everything in their camper. So, you know, your call. But that kind of explains where to go. It kind of gives you a sneak peek of the Rosie E panel. You guys have seen us try to start an air compressor with the Rosie. I wish I'd have got you a video at SPI, but we had a Rosie there with 7,000, 8,000 watts of light bulbs. Maybe it was 9,000 watts. I can't remember how many watts of light bulbs now. It was a lot, like maybe 7,000 or 8,000 watts. And then 4 of the DeWalt 120 volt Home Depot type, you know, air compressors. And what impressed me the most about the Rosie, well, two things actually. The first day we got it going, there was a short in L1 in the booth. So when you turn Rosie on, she'd make a really loud, you know, angry noise, and then basically just go quiet and make power on leg 2 only. So leg 1 was dead short to ground in a breaker box in the booth itself. So Rosie would like try to power that short for about 5 seconds and then shut off leg 1, but keep powering leg 2. But what really impressed me with Rosie was having all of those light bulbs, like 8,000 or 9,000 watts light bulbs, all 4 air compressors, all on electrically, but the Rosie battery breaker off. And any of you that know inverters real well know that, you know, you want to start the inverter first and then put the load to it. You could reach over and snap the Rosie on, it would start up and fire all that equipment up. It was a 22,000 watt load, surge load, and then it stabled in at, I think we figured 17,000 watts running load. And the Rosie would start that no problem on 4 little Costco car batteries. So this is an exciting thing. We're excited to get this one going, get some self-consumption stuff going, put some time on it. Like I said, all these breakers over here, this is your AC in. This will be AC in 2 when Rosie 2.0 comes out. We'll have dual inputs. And then these slots over here for PV, like if you want to put a classic or something over here, you can put breakers in here. We just put them in there to fill the hole. And the Hawke's Bay breaker box, I'm not sure we showed you guys that on the system in Maine, but it's pretty well thought out too. The ground bar is in the back. It's got plenty of knockouts. 125 amp breaker for the Hawke's Bay output. It does have a jumper here so you can connect your battery cable to it. In our case, we're using number 2 X-Flex that we'll go down to the serverette batteries with. So it's got an easy way to connect that. You guys saw the SPD. The other interesting thing that they've done with the Hawke's Bay and the Barcelona is they have a self-contained circuit in them that will trip the PV breaker if the battery goes above 68 volts, I think it is. And that was driven by a couple of the lithium manufacturers who've had other 600 volt charge controllers that have failed and applied 600 volts to the battery and caused really bad problems. So this way, if there is an actual problem, that can trip and kill everything. The other thing it can do too is this can be tripped if there's an arc fault. So the arc fault and ground fault module is already installed in here. We didn't show you that. I think we showed you in a video where we tested arc fault. But that's all done in there too, and that can intertwine into that. So kind of cool stuff. It's really exciting to be able to play with it, especially in our Kermit green room. So yeah, Sue likes bright colors, and this is a small room, and it needed a coat of paint and just a little sprucing up. This is a kind of a laundry room, storage room, whatever you want to call it. So she picked this color. Maybe I picked this color, actually.
You picked this color.
Yeah, I think she gave me some choices, and I picked this color out of the choices. So I don't mind bright colors. At the end of the day, it's a gallon of paint. So if you don't like it, you change it. But I don't know, hopefully that was kind of helpful with the SPDs, and maybe you learned something, and definitely stay tuned. We're going to start cracking into this stuff really quick here. We're going to get our freezer set up right over here in this corner. It's going to be our studio. We got our green wall. I can start giving you the weather forecast. Up here in Maine, it's warmer than it is in Florida this morning, which is really screwed up. No, just kidding. Anyway, thanks for watching, guys. Don't forget to like and subscribe.